the domain. I need to know what's the domain. So can somebody remind me what domain is? Where do I look?
The x-axis.
The x-axis, exactly, because domain, I'm just going to put this over here. Okay. Domain, it means all of the what?
Inputs.
Inputs. So automatically, if I'm looking for the domain, I know that I'm looking at all of the input values. So what's the smallest input value that is on this graph?
0.
Mhm.
0.
Good. You always want to look at the first point. So it's 0, 0. And what is the largest input value?
20.
20.
6.
Okay. So is it 20 or is it 6? That's the question.
Oh.
6.
So I've got two different points, the 6 and the 20. What's the coordinate point for 6?
0. 2.
What's the coordinate point for 6? On that 6, what's the full coordinate point?
0, 6.
6, 0, 6, 0.
Is it 6, 0 or 0, 6?
0,
6.
0.
Oh, I'm getting like two different answers. So think about it. We know that it's on the x-axis, right? The 6 is the x. And remember, we go x comma y. So is the 6 the first number or the second number?
The second number.
The first.
The first.
The first.
It's the first. So it's 6 comma 0. Remember, because it goes x, y. So the x is 6 and the 0 is the y. Okay, so then I know that, what about the top point? What's that one called? Or what's the coordinate point for that one? The blue point.
20.
Yeah, 3 comma 20. So even though 20 is the highest number, is 20 the biggest input?
No.
No, what's the biggest input value?
6.
6.
6. 20 is not an input, 20 is the output. So the biggest inputs are from 0 to 6. So B and D are out because B and D are not talking about the domain. What is from 0 to 20? Not the domain, but the...
Output.
Range.
Yeah,
Range?
the outputs, which are called the range. So that's the difference. Remember, input versus output. You got to know the difference between them in order to answer this type of question. So B was actually not the correct answer, but now see if you chose B, see if you can change your mind. Is it going to be A or is it going to be C? Think about it again for another 30 seconds and then we'll decide on our answer. Okay, so the only difference between A and C is, are we talking about integers or are we talking about real numbers? So who can remind me, what is an integer? We did this yesterday.
A negative or positive number.
Negative or positive, and there's one more specific thing about it. Who remembers?
Counting numbers?
Yeah, counting numbers. You got it. Which means, somebody give me an example of an integer, something that is an integer.
3.
3, positive 3. Give me a different one.
-5.
Negative 5. Now give me an example of something that's not an integer.
6.
Is 6 a...
0.
1.6.
Okay, so I heard 6. Is 6 a counting number? Can you count to 6?
Yes.
Yeah. Yeah, so 6 is definitely an integer. 0, can you count 0? If there's nothing there, yeah. 0 is an integer. But 1.6, what's wrong with 1.6?
Decimal.
Decimals, exactly. So decimals and fractions are not integers. Now, all real numbers kind of sounds like exactly what it is. All real numbers is basically just everything. Every type of number. So that includes positives, negatives, decimals, fractions, everything. So in this case, is my rocket, because this is measuring the rocket, right? The time that the rocket is like in the air. Would this be integers or real numbers?
Real numbers.
Real number. C.
Good. C, all real numbers, because time doesn't skip. You can't just teleport, right? Time doesn't skip any numbers. So whenever we're talking about time, especially, that's always going to be all real numbers because time doesn't skip from 1 to 2. It takes everything in between. So any questions on this one? I want to make sure we understand this concept because I saw most people did not get this one right. I think only 2 or 3 people got this one right. So does anybody have any remaining questions on it? If you picked the wrong answer, give me a thumbs up if you understand how to do it correctly now. Good. Okay, and if you don't have a thumbs up, make sure you ask me any questions if there's anything you're still unsure about. And that goes for today's entire class. All right, so today we're going to be learning this is the very last topic in this chapter. So today we're going to be learning about something called sequences. And since today is the last topic, that means tomorrow, Friday, and Monday, we're going to be reviewing everything that we've learned up to this point so that on Tuesday of next week, you guys are ready for your first test. So starting tomorrow, we're going to be reviewing, and then you test on next Tuesday. So make sure throughout this entire review process that you guys are asking those questions, testing yourselves, making sure you know what you don't know. So let's go ahead and begin. So a sequence, we're going to write down the following definition. So a sequence is a list of numbers in a specific order. Each element in a sequence is called a term. In a sequence, each term has a position number. So just start by writing that down. I'll give you guys 30 seconds. I'll give you guys 1 minute to write it down. All right, so finish up writing and we're gonna move on to our first problem of the day. So just before I head on to that page, basically with a sequence, the pattern might not always be so obvious. So in this one, it's like, oh, okay, we're just adding by 2. That's pretty easy. But a lot of times it's going to have a much more difficult pattern. So instead of being able to figure it out using our eyes, there's going to be kind of like functions. There's going to be a rule that we can follow to know what comes next. So I'm going to go ahead and move on to the next slide. Unless somebody desperately needs me to stay on this one for a couple more seconds. Okay. All right. So in this page, I don't want you to copy everything down because we'll be here all day. So don't copy anything yet. However, I just want you to notice a couple of things. So I took the same exact sequence from the previous page, 7, 9, 11, 13, and they made a table out of it. So on the table, I've got my sequence, so 7, 9, 11, 13, 15, 17. And then the top row, that is my position numbers. So remember how I said the number 7 is the first one, so that's position number 1. 9 is the second one, so that gets the 2. Then we have the 3, 4, 5, and 6. So this is very similar to a function. And in fact, sequences are a type of function. So all the sequences we're going to be seeing today, they are pretty much exactly like functions. It's just a special type of function. So let's take a look at some of the words they use here. Notice how the position number is my domain, and then the terms are the range. So which one is my input?
The domain.
Good, the domain is my inputs. So all of these position numbers are my input numbers, and then the terms are my output. So again, it's very similar to a function. So since they're kind of like functions, we can use function notation to evaluate all of the different terms. So take a look. What I do want you to copy down is each of these here, each of those little problems. So based on the table, what would be f of 1?
7.
7.
Exactly. So since my input is 1, my output is 7. When my input is 3, what's my output?
11.
11. When my input is 6,
17.
17. Now on the flip side, you can go the other way around. If you know the output is 13, you can go back and check what's the input that gives me a 13.
4.
4. And what's the input that gives me 15?
5.
5.
So based on a table, if you have a table in front of you, or even if all you have is a list of numbers, with a list of numbers, you can assign each of them the position number and then figure out how to evaluate, just like this. Just how do I evaluate for a certain number? So this is kind of like the basics. Do I have any questions on sort of these basics of what sequences are?
No.
Cool.
No.
All right, so before I go to the next page, we're going to write one more thing, which is that on tests and on different documents, sometimes you'll see the function notation written in a different way, but it's still going to give us the same answers. So a different way of writing this, a different way of writing f of 1 would be the letter A with a little 1 under it. So that little 1 under it, we call it, I would say, A sub 1 or A of 1. It's the same thing. It's just a different way of notating it. So you might see this as well. So A of 1 would be 7, A sub 3, 11, A sub 6, 17, A sub 4 is 13, and A sub 5 is 15. So again, we're going to see a couple of problems at the end of today's lesson that use this type of notation instead. And I don't want you guys to get tripped up by it because it literally it's just a different way of writing the same exact thing. So any questions, comments, concerns? All right, cool. Okay, so this is the same exact chart. We're not copying anything new. 7, 9, 11, 15. Okay, same chart, just a different problem. Can I have a volunteer read after discussion?
What does f of 4 equals 13 mean in the context of the go-kart problem?
Cool. So a lot of times you're going to have real world examples, kind of like we did yesterday. So in this real world example, can anyone tell me what this statement means using words? What does it mean when I say f of 4 equals 13?
Yeah, 4 is the input and 13 is the output.
Okay, yeah. So 4 is my input. 13 is my output. And now read, if you need to, because if you haven't read it already, read this part right here because it's telling you about what's actually happening in this problem.
So like, would it be 4 times? I mean, I don't know how to explain this because like it's the cause of something.
You got
When
it,
you
yeah.
write 1.
Okay, yeah, you're piecing it together. So we know that the term, so terms are my outputs. So the output is the cost, and the input is the number of laps. So if the input is the number of laps and the output is the cost, can anyone give me a sentence to explain what f of 4 equals 13 means?
Writing 4 laps equals $13.
Mhm. Exactly. So 4 laps costs $13. So with any type of problem like this, it's very important, just like we did yesterday, what is my input representing? What is my output representing? And when I put it together, what does that actually mean in the real world? Because if I'm just saying, oh, input and output, that doesn't mean anything. You have to actually put it to words. So do I have any questions on how we got this statement?
No.
Okay. All right, so now let's look at a different sequence. Now, remember, like I said, sometimes the pattern is really easy to see. Sometimes the pattern is not. And when it's not, we can write an explicit rule. So this is kind of a lot of words. You know, a lot of times these definitions, they love to use big words and make it sound confusing, but I will make sure that you understand. So just start out, I'll give you a minute to write the definition, and then we'll talk about what it means. Okay. You can finish writing if you're not done, because I'm not going to move yet, but I'm going to go ahead and I'm going to read this definition out loud. So, an explicit rule for a sequence defines the nth term as a function of n for any whole number n greater than 0. So that's kind of a mouthful. There's a lot going on there. But basically what it's saying is you can have a rule where if you plug in n, you can find out your output. So if you have an input of n, you can plug it in and see what you get for f of n. The thing is with these types of rules with a sequence is that you can only plug in whole numbers greater than 0. So when you plug in your inputs are only going to be 1, 2, 3, 4, 5, 6, on and on. So only whole numbers greater than 0. And then it says, explicit rules can be used to find any specific term in a sequence without finding any of the previous terms. So what that's saying is that you could pretty much figure out any number in this sequence, in this pattern, without having to know what came before. Because all you need to do is simply plug in the number that you're trying to find. So let's go ahead and do example 1. In example 1, we're going to write the first 4 terms of the sequence using this rule. So my rule is what I'm going to follow to find out the first 4 terms. So I'm going to make a table kind of like the previous problem. And I know that I have my position numbers. And then I'm going to have my terms. So I want you guys to make a little table just like this one. That way we can fill it in and keep everything nice and organized. And as a reminder, what should I be putting in for my position numbers?
Never mind. I don't know.
The n,
The n, so basically the values
input.
you're going to input, exactly, the inputs, the values that you're about to plug in. And since it's asking me to find the first 4 terms, what are the first 4 terms? It's going to be number 1, number 2, number 3, and number 4. So it's basically just telling me to find the first 4 numbers in this pattern. So I'm going to plug in a 1, I'm going to plug in a 2, then a 3, and then a 4. So let's start with plugging in my 1. So my first input is 1. So everywhere I see an n, I'm going to replace it with a 1. This is just like what we did the last couple days. And once I have that in, I'm going to evaluate it. So 1 squared, 1 to the power of 2, gives me what?
1.
1, yeah, because 1 times 1 is just 1. So now I have f of 1 is 1 plus 2. And what's 1 plus 2?
3.
3. So my first term in the sequence is 3. Then I don't know, I don't know the pattern to get to the next one. So instead of thinking about it like a pattern, I'm just going to use my rule again and plug in the next term. So instead of plugging in a 1, now I'm going to plug in a 2. I want to find f of 2. So very same thing. All I'm going to do is I'm going to plug in my 2 and see what I get. So what's 2 squared?
4.
4.
Mhm. And then 4 plus 2?
6.
6, exactly. So that's my second term. And now I want you guys to find the third and the fourth. So do the math, plug in the 3, plug in the 4, and see what you get. I'm going to give you a minute.
Miss, I am so confused.
Ask your question. What you're confused about?
The whole thing that you did, like on the left.
The math?
Yeah, that.
Okay. All I'm doing is I'm evaluating. Use PEMDAS. So PEMDAS tells me to do my exponent first. So that's why I did 2 to the power of 2. What's 2 to the power of 2?
Wait, that means to multiply.
2 times 2.
Oh,
One's supposed to be 4, because 1 to the power of 2 is 2, isn't it?
Nope. What's 1 to the power of 2?
Even if one has like an exponent of 100, it'll still become 1.
Because 1 times 1 is 1. 1 times 1 times 1 times 1 times 1, still 1.
Oh, okay.
2 times 2 is 2. Now my f of 3, I'm plugging in 3, so what's 3 times 3?
9.
9.
9. And then 9 plus 2?
11.
11. So I get 11 for my third term. And now I'm plugging in a 4. 4 times 4 is,
16.
yeah, 16. And then 16 plus 2?
18.
18.
18. So my final term, or my fourth term, is 18. So there are my 4 first terms of the sequence, and I'm going to write them in a list. And it's 3, 6, 11, 18. And then I'm going to do dot, 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 because I know that that continues on. Even though I haven't found the next number, I know that it continues on. So the table is really useful for organizing everything, but when you actually write the sequence, you can write it as a list. So now, any other questions? So I kind of tried to clear up the math. So do I have any other questions on the actual math that I did?
Miss, why did you add 2 to everyone?
Because the rule tells me to do so. I'm following my rule. What does the rule say? The rule says plug in a value for n, raise it to the power of 2, and then add 2. That's my rule.
You only change the input.
Yeah. All you
Or
do
the
is you
end.
change, exactly. All you do is you change whatever number you're plugging in. That's the only thing that changes. And the rule might be different for the next problem. So in fact, we're going to do another problem. It has a different rule, but you're still going to do that same idea. You're going to plug in a different value. So y'all ready for the next problem? Try it by yourselves?
No.
Yes.
Okay. Oh, actually, my bad. It's the same rule. But Go ahead and can I have a volunteer read the first problem here?
Communicate mathematical ideas. Explain how to find 20th term to the sequence defined by the explicit rule Fn equals n to the power of 2 plus 2.
Perfect. So how would I find the 20th term? So far, I only have 4. This is the same one as last time, right? So right now I know what it was
Do you plug in 20 with the n?
exactly. Because right now, all I have is 3, 6, 11, 18. I don't know anything else. I only know up to the 4th term. So in order to find the 20th term, just like, who was that? Elsie? I'm sorry, I wasn't looking.
Yeah.
Yeah, just like Ilse said, I can still use the same rule and I'm going to plug in a 20 and see what I get. So I'm going to find f of 20. Not 2, 20. So go ahead and you try it on your own. What is f of 20 going to be? Good, I'm seeing lots of correct answers. All right, what's 20 squared?
40.
400.
400. 20 times 20 is 400. And then 400 plus 2
402.
is 402. So when I say f of 20 equals 402, or remember, sometimes you might see it like this, a of 20 is 402. I know that this means that the 20th term in the sequence is 402. So this pattern is going to keep going and going and going. And then eventually the 20th number in that pattern is going to be 402. And then it keeps going after that. So any final questions on how to find a term, how to evaluate a sequence? Okay, the next problem is a little bit different. It's similar, but a little bit different. So can I have a volunteer read problem B?
Me.
Go ahead.
The number 125 is a term of the sequence defined by the explicit rule f of n equals 3n plus 2. Which term in the sequence is 125? Justify your answer.
Okay, so now I have a different rule. So notice,
Miss, I'm still confused on this entire topic.
Miss, can I explain it to her?
try your best, go.
Okay, Melanie, you see how it says F20, right?
Yeah.
You see how it says Fn and then n and the 2 and the plus 2?
Mm-hmm.
So the problem is 20, how to find the 20th term. So you're finding 20. So the n is going to turn to 20.
So you're replacing the n with a 20 or
Yes.
whatever term it tells you.
Exactly. So if
Oh,
it said,
great.
what is the 100th term, you would replace that n with 100. If it said, what is the 52nd term, you're going to replace that n with a 52. Whatever number it tells you.
Okay.
Thank you. Thank you, Marian.
You're welcome, Miss.
Okay,
Period.
so now,
Period.
now we have a different rule. So we're no longer looking at the rule at the top. We have a completely different rule that I highlighted in purple. So I'm going to rewrite it down here. F of n equals 3n plus 2. And just like the problem says, now it's kind of backwards because what do I know? I know that the number 125 is a term in the sequence. So what does that mean? It means that the sequence has a number, another number, another number, another number, and then eventually you get 125, and then it keeps going. However, we don't know what any of those numbers are. We don't know what position the 125 is in. We don't know if that's the first number. We don't know if that's the second number. We don't know if that's the third number. All we know is that it exists in that list somewhere. So I have a rule. Would it be possible for me to figure out what position the 125 is in? Think about it to yourself for like 30 seconds. Does anyone think that they might be able to figure it out?
Wasn't it the thing that you did last time in the first? I don't know what it was, but like you know how it in the first one, like in N it didn't have nothing, and then in the next to the equal sign it had a number. Like I don't know what it was.
You're onto something. It is what you're talking about is true. Let's see if anyone else can get a little closer to it.
So it will still be the same. So the N will still be for 125.
So no, because I'm no longer looking for the term, I'm looking for the number. So it's a little confusing to understand, but basically what this is saying is that 125 is not the input, 125 is my output. In the problem we just did where we plugged in 20, that's because 20 is the input, because it's the position number. Remember how this is 1, like if I made this into a table, this would be 1, that would be 2, this one would be 3, 4, and then there would be a bunch, and then you would get to 20. So 20 was my input. Well, in this case, it's the other way around. 125 is my output, and I'm trying to figure out what was the input that gave me 125. So we're thinking about this backwards now.
Miss, is it like possible you could do like 3n plus 2 equals 125?
That sure is. That's exactly what we're going to do. Because remember, we don't know what n is. We don't know what the input is, but we do know that whatever that input is, it's going to equal 125. So what I can do is I can make my function equal to.
So it could divide.
Yeah, we're going to divide. We're also going to do one more thing before we divide. So I'm making my whole function, my whole rule, this rule right here, all I'm doing is I'm making it equal to the number that I want. And the number I want is 125. So now I need to know what's the value of n. So what do I need to do to find the value of n?
Subtract 2 on both sides.
Minus 2 minus 2. What's 125 minus 2?
122.
123.
Oh, my bad, miss.
123. And now, eventually, what can I do?
Divided by 3.
Now I can divide that by 3. So what's 123 divided by 3?
41.
41. So I know now that the input that gives me 125, the input is 41, the output is 125, which means that if I were to make this into a table, this would be number 41, this one would be number 40, 39, 38, 37, and so forth. 42, just like that. So this is definitely kind of like the trickiest thing you're going to have to do if they ask you this on a test. But remember, at the end of the day, try and see, is it asking me for the input or is it asking me for the output? In example A, it asked you for the input, so you plug it in. Example B, it asks you for the output, so instead what you have to do is set it equal to that number.
So you would do this every time, like it asks you for the output.
Yes. So in this case, let's see, how do I make this simple?
Miss was kind of easy.
It's really just about reading. It's really, you just gotta read as carefully. I forget which period I said this in, but yesterday someone was like, Miss, this is basically ELA. And I'm like, yeah, it is. It literally is, because you just have to read. So yeah, in example A, we were able to plug in the input. In example B, I had to put in the output. But if it's still a little confusing, we're going to be reviewing all of this on the rest of the week. So hopefully by the end of the week, it'll make a little bit more sense.
Yay.
Let's do another different type of problem. We have one last definition.
I was just gonna ask you that.
One last definition, just this right here. So previously we were talking about explicit rules. Now we're going to be talking about a recursive rule, and it's similar, but just a little bit different. So go ahead and take 1 minute to write down the definition. Okay. If you're still writing, keep writing. I'm just going to kind of start explaining. So a recursive rule.
Miss, that's a long thing. Equation.
I know. And I'll explain every part. So a recursive rule defines the nth term, so that means you can plug in whatever number you want, by relating it to one or more previous terms. So here's an example. So I have f of 1 equals 4, and then f of n equals f of n minus 1 plus 10. So kind of looks like a little confusing, but once I explain it, trust me, it'll make way more sense. So I'm going to split this up. So I know I have f of 1 equals 4. What does that statement tell me?
That, wait, I think 1 is the input
1 is the input
and 4 is the output.
and 4 is the output. So this is basically telling me the first number in this pattern is 4. The first term is 4. That's what the first part of this rule tells me. The second part of the rule tells me how to find the next number. So let me write that part down. F of n equals f of n minus 1 plus 10. So what is this? I'm going to define each little part of this. F of n just means
You're looking for the position.
So f of n is the next.
Do we write what you're writing?
I do want you to write this down, yeah, because it can get confusing. I want to make sure you guys understand what this all means. Okay, so the next term. The next term is going to be f of n minus 1 means to go back. So this tells me to look at the previous term. And what do I do to that previous term? I'm going to add 10. So this is kind of telling me the pattern that the numbers are going by. It's saying, okay, if you want to know the next number, you got to look back to the previous number and add 10 to get the next number. So it's kind of like, I know like Melanie was saying, this is really, really long. But even though it's really long, it actually makes it kind of easy to see what the pattern is. Because in this case, my pattern to go from one number to the next, all I need to do is add 10. So if my first term is 4, what's my next term going to be?
14.
14. Then what comes next? 24. Then
34.
34.
28.
34. What are we adding each time?
10.
10. Because my rule literally just tells me add 10 to the previous number.
Oh,
Miss,
so we're just
I had it
finding out
for-
what the ends mean?
So yeah, so basically, even though, like I said, like this whole equation kind of looks confusing, it's literally telling you, just with math, it's telling you what to do to the previous number to get the next one. So I'm going to just make this a little bit smaller. I'm going to rewrite my sequence really quick. I'm going to make it in a chart just to keep things organized. So again, what was my first term?
4.
4. To get my second term, I look back at the first term and I add 10. So my next term is
14.
14. And just like that, term number 3 is 24. 4 is 34. 5 would be 44, and so on. So no, try and connect the dots. Look at how that equation is telling you what to do. So do I have any questions on how to kind of read that equation?
No.
Wait, Miss, hold on.
Yeah, take 30 seconds. And then we're going to do, I'll give you another problem to practice this.
Miss, like I get it, but like then what's the whole point of the equation if you're just gonna?
So the
I
whole
don't
point
know.
of the equation is because sometimes it's going to be, you know what, hold that question. When we do the practice problems at the end, you'll see why. I know a lot of times when you're learning something new, it's like, I don't even know what I don't know. But I promise it'll make more sense. Let's do a problem. Okay, so this is a different rule. It's a little similar, but it's different. So just like the previous problem, see if you can figure out what that rule is telling you. Don't worry about all of these columns in the middle because that's just going to confuse you. But see if you can find the first 4 terms of this sequence. So what is that column on the right? What am I going to fill out based on this rule? Take a minute.
F of
Take a
1.
minute. Take a minute on your own. Then I'll take questions after. Okay. So let's see. See if we understand. So what is f of 1 going to be?
The first term.
The first term. And it tells you in the rule what that is. So what does it say it is?
4.
Yeah. It says so right in the rule. You don't have to look any further. It says it right here. F of 1 equals 4. Now for the next term, what do I do to the previous one to get the next one?
Add 5.
Good. It says it right there. We're going to take that previous term, add 5. What do we get?
9.
9.
9. And then we're just going to continue that pattern. So what comes next?
14.
14. And then
19.
19.
19. Exactly. So recursive rules are different because rather than plugging in 1, plugging in 2, plugging in 3, whatever, you take whatever you just had and you just follow the pattern to get the next number. So that's why they're a little bit different. But do I have any questions? I know it was confusing at first, but do we feel a little bit better about it now? Any questions?
No.
This one looks easier than the other one.
Yeah, that's the weird thing is that it's written a little more confusing, but then it's actually easier.
Oh, Miss, what do we put in the little slot?
So in the middle,
Yeah,
the
like
part
for
I
number
crossed out?
2.
So in what they were trying to do, this is from the textbook, but basically we knew that f of 1 equals 4. To get the next term, I have to look back, right? So if I'm looking for f of 2, I got to look at f of 1 and add 5. So this means I have to do 4 plus 5, which is 9. So it's kind of like writing it all out. The reason I don't like this is because it honestly makes it more confusing than if you just figure out the pattern and go. Sometimes the textbook, like it goes too much, it does too much. Okay, let's try another one. So remember how I said at the beginning, they might write it a different way. So I want to make sure that we understand how to do it, even if they're writing it in the different way of writing. So can I have a volunteer read for us?
Neil listed the number of flowers that bloomed in his garden each week below. Each week there
There
are more flowers bloomed than the previous week.
Perfect. So here's my list. And remember, when I have a list, it's always a good idea to turn it into a table. That way you can clearly keep track of your inputs and your outputs. So if you want to follow along with me, you can copy down this table. So my first term is 2, 4, 8, 16, 32, 64. Which ones are my inputs?
The 1, 2, 3, 4, 5, 6.
Good. This is my input, and this is my output. Okay. And on a test, the way it's going to look is basically like this. They're going to show you the pattern, and then they're going to ask you which rule is the correct rule. So the best way to do this type of problem is to test out each answer choice until you find the correct one. So I'm going to start out by testing out answer choice A. So I'm just going to write down answer choice A. And we're going to literally plug in any number you want from the table and see if when you follow that rule, see if it works out. So let me have a volunteer tell me any random pair of numbers from this table. Which one should I plug in?
4.
2.
Okay,
3.
I heard 4, I heard 2, I heard 3. Well, 3's in the middle, so I'll choose 3. So if my input is 3, what should my output be?
8.
I should get at 8. So let's see if that happens. So I'm going to plug in a 3. So my n, anytime I see an n, it's going to be a 3, right? That's my first
Isn't
step.
it supposed to be that one minus 2 or no?
Yeah, minus 1 is what
Oh.
it's saying. So since I plugged in a 3, 3 minus 1 gives me 2. So what is this saying? This is saying 2 times a of 2. So that means I have to look back, and when my input was 2, what was my output?
4?
4, right from the table. When my input was 2, my output was 4. So what's this saying? This is saying to do 2 times 4. And what's 2 times 4?
8.
8. So does this pass the test? I plugged in a 3 and I got out an 8. Does that pass the test? Does it match with my
Yes.
table?
Yes.
Yes. And you could try it out with any number from your table to see if it works out. So would you guys like me to try a different number?
Yeah, miss. Because
Okay.
I was writing it down instead of listening.
Okay, let's try plugging in 6. So I'm going to do the same thing, but I'm just going to plug in 6 instead. So I plugged in 6. So I replaced my n with a 6. So now I got to just subtract what's 6 minus 1.
5.
Good. And what this is telling me is to look at A of 5 or F of 5. If I look back at my table, what was F of 5?
32.
32. So what's this telling me to do? This is telling me to do 2 times 32. And what's 2 times 32?
64.
54.
Does it match?
Yes.
Yes.
Hold on, let me write.
Miss, I get
Yeah,
so
Miss.
confused. I'm sorry.
We'll do one more. I'll do one more after this. So if you're still confused, I'm going to show you what it looks like when it's not the right answer. So we already proved that A is correct. But I'm going
It's
to
just
show
that
you.
seeing all these numbers and letters makes me so
But Miss,
confused.
how
You
is
gotta-
it 32?
How is it 32? Because this right here, when I say A of 5, it's telling me to look at my table and see what I got for 5. What did I get for 5? I got 32.
32.
So that's why I plugged in 32. Same thing in the previous
Oh,
problem.
and then you're gonna multiply it by 2.
Mhm.
Okay, Miss.
In the first time I did it, same thing. It was asking me what is A of 2? That meant go look in the table. What did you get for 2? You got 4. So that's why I plugged in 4. But like I said, I'm going to do it one more time. So I'm going to erase my first example. I'm going to test one that I know is wrong. So I'm going to show you why C is incorrect. Ready? I'm going to get rid of all these colors so we don't get all confused. Okay. So answer choice C is A of n equals 2A of n plus 2. So let's pick a random set of numbers from the table. Who would like to pick any one of them?
4.
Okay, let's do 4. Okay, so I'm going to try to find A of 4. And when I get my answer, what do I want my answer to be?
16.
16.
I want it to be 16. So let's see if I get 16. I probably won't because I already know this is the wrong answer. Okay,
So we only substitute the n's.
yes. Always the n, not the A, the n. Okay, so A sub 4. Here we go. What's 4 plus 2?
6.
6.
So, Miss, for the answers to be right, you have to add by the first number in the input.
For the number to be right, so let me show you what it means for the number to be wrong. So let me finish this example and you'll see what it looks like when it's wrong. Okay, so here's how far we got so far. Now, this is telling me to look at my table, look at the 6th term. What is the 6th term?
64.
64.
64. So now I'm going to go back to my equation and plug in a 64. And what's 2 times 64?
128.
128. Does that match with what I wanted to get in my table?
No.
No.
No, because I wanted to get 16. If I plug in a 4, if it was the right answer, I should have gotten 16, but I didn't. So that's how I know that C is not the right rule for me. Does that?
Yes, but you know how you did for the 6,
Mm-hmm,
the other example?
mm-hmm.
What, like I don't know, it's because you said, oh, you wanted to get 16, right?
Yeah.
But for this one, for the example that you did here, you got 64. But I know you were doing 6.
Mm-hmm.
I don't know. I don't know how to explain it.
So you want me to explain this again?
Like I get it, but
Well,
I
in
don't know.
this case, okay, let's step back. Do I have like an okay on why C is wrong?
Yeah.
Okay. It's wrong because 128 is not what you should get. You should get 16. So that one's wrong. Now, over on the right side, I was still testing answer choice A, and this one was correct because when I plugged in a 6, I got 64. And that's exactly what I wanted to get because that's the pattern and that's on the table. The sixth term should be 64. Since that's what I got, I know that that is a correct answer.
Yeah, but then why is there a 5?
Why is there a 5? Because in my rule, what does my rule tell me to do? Let me write the original rule.
Oh, I see.
This was answer choice A, right? Answer choice A is 2 times A and minus 1. Since I plugged in a 6 for n, I plugged in a 6 for n, so I had to do 6 minus 1. That's where the 5 came from.
Yeah, you're right.
Okay, let's do another. The more we practice, the better we're gonna get. So let's do another. Can I have a volunteer read? We're talking about ducks. I love ducks.
A researcher determined the amount of ducks that were in a pond over a 4-year time span. The results are shown in the table below. Select the equation that best models the amount of ducks that will be in the pond during the nth year.
Perfect. All right. So they gave us the table already. Remember, when it's in a list, you'll want to make the table, but in this case, the table's already made for you. So which ones are my inputs?
The years.
The year.
Good. That's my input, and then that means that my ducks are my outputs. And I'm trying to figure out which of these equations is the correct one. So just like we did in the previous problem, I'm going to test out my answers. Which answer would you guys like to test first? A, B, C, or D?
B.
Sure, let's test out B. So we're trying to see if B is correct. So I'm going to write down my function or my explicit rule. And then I'm going to go over to my table and pick a pair of input and output that I can test. So I can test any of these. Which one should I test?
1 and 64.
1 and 64. Sounds good to me. So remember, which number is my input?
1.
The 1.
1. So which variable am I going to turn into a 1?
The n.
The n. So now I'm looking for A of 1. And I'm going to replace my n with a 1. And what should I get? What do I want to get?
64.
64.
I want it to be a 64. So let's see. Well, I got to do 1 minus 1. What's 1 minus 1?
0.
0. So this is 14 times 0, which is
0.
64. Oh.
14 times 0 is 0. So this gives me 50 plus 0. Do I get the right answer?
No.
No. So I just tested this one. I know that one's wrong. Somebody give me a different one to test.
D.
The 3.
All right, let's try D. So I already eliminated answer choice B. Now I'm going to try out answer choice D. Should I use the same numbers or would anyone like to test using different numbers?
4.
Okay, sounds good. So remember, you can pick any pair of numbers. So for this one, we're going to use 4. And when I plug in 4, I should get 106. So here we go. I'm plugging in a 4. And now I do my math. 4 minus 1 is, oops,
3.
is 3. Hold on, I dropped my pencil. Okay. Is 3. So 1 plus 64 times 3. And what's 64 times 3?
192.
192. And 192 plus 1?
193.
193. So is that correct?
No.
No, because I didn't get 106. I should have gotten 106 and I didn't. So that one's out as well. All right, we're down to 2 final ones. What should I test?
8.
Let's go for it. And should I keep the same numbers or plug in different numbers?
2.
I'm gonna plug in 2. Sounds good to me. You can pick any pair. When I plug in 2, I should get 78. Let's see what I get. So 64 plus 14, 2 minus 1. What's 2 minus 1?
1.
1. And what's 14 times 1?
14.
14.
Here's 14. And what's 64 plus 14?
78.
78. Guess what? We found our match. This is correct, so I know that my answer is A.
Miss, you put 72.
Oh, you're right. My bad. There we go. So that's the strategy, guys. That's what you're going to do. If you have a problem like this on a test, you're going to want to plug in your input and see if you get the correct output. If it does, if it matches, then that's how you know that's the right answer.
Miss, are we gonna have a Khan Academy on this?
No.
Okay, good. That's too much.
The homework that's due tonight is the only homework you have all week. All right, I think I have one more like this. Yeah. Wait. Actually, let's do this one because it's kind of the same thing, but now we're going backwards. So can I have a volunteer read this one for us?
A sequence is defined by the function f of n equals f of n plus 1 plus 5. Wait, minus 1 plus 5, where n represents the number of the term for n. Wait, I forgot what that sign means, Miss.
Does it look like an L or a backwards
Greater.
L? Greater than.
N greater than 1 and f of 1 equals negative 4. What are the first 4 terms of the sequence?
Good. All right. So I'm looking for the first 4 terms. So what am I trying to find? F of what?
The 4 terms.
The first 4 terms. So in other words, I'm looking for F of
4.
1, 2, and 3, and 4.
1, 2, exactly, 3, and 4.
Miss, are we writing this?
Yes, ma'am. Go ahead and write it. So I want you guys to try this one on your own. I'm not going to say anything else. I want to see how much you already know. Try it just on your own. See if you can figure out what you're supposed to do. I'm going to give you 2 minutes. Read the problem carefully. Reread it if you need to. All right, that's time. Okay, let's see. So I need to find the first 4 terms, starting with f of 1. Read the problem carefully. How do I figure out f of 1?
You substitute the one with the n.
Not even that. Read it very carefully.
You take one of the numbers from A.
From A, nope. I'm not going to test the answer choices yet.
Wait, can you repeat the question, please?
How do I know f of 1?
It gives it in the question.
It gives it to you in the question. Where does it give it to you?
F of 1 equals -4.
F of 1 equals -4. It says it right here. So you don't have to do anything for f of 1. It already gives it to you. F of 1 equals -4. Straight off right from the start, you can get rid of 2 answer choices. Which ones can I get rid of?
A and C.
A and C.
A and C. That's it. So that's why it's so important to read the questions, guys, because so easy you can just get rid of 2 right off the bat. Now I need to find f of 2. Now I have to go and look at my rule. What does my rule tell me to do?
Add 5.
Add 5. Notice, remember what this f of n minus 1 simply means the previous number. Take the previous number and add 5. So if I'm looking for f of 2, I go back and I look at -4, and I'm going to add 5. What would my next number be?
1.
1. All you do is you add 5. What's next after that?
6.
6.
6. And then finally?
11.
11. Which means my answer is D. So again, you guys, I know that this is kind of like the toughest thing. I kind of left the hardest one for last, but you know, the more and more you practice with this kind of stuff, the easier it's going to get. So if you're still, like I said, if you're still feeling a little iffy about it, we're going to get more of a chance to practice on Friday specifically. So look out for Friday. Make sure that we're asking good questions and trying to make sense of it. Okay. So that's it for me for today. It's 3:50. My one reminder is that you have homework due tonight at midnight. That it's not new homework. It's the same homework I gave on Monday. So make sure if you haven't done it yet, it is due at midnight tonight and it goes in the grade book. So get it done. Any questions?
No.
All right, y'all. Have a good night. See you tomorrow.
Bye, Miss.
Bye.
Bye.
Have a nice day.
Thank you.
Bye, Miss.
Thank you. Bye.